All right, welcome, Math 8. Happy to have you back. Today we're going to talk about right triangles. So go ahead, grab something to write with, something to write on, and write down the perfect squares from 1 to 15. Go ahead and pause the video while you do this. All right, so here are our perfect squares from 1 to 15. If you did not get any of these, please go ahead and fix them. Remember, when we're squaring something, we're multiplying it by itself, not by 2. All right, our goal today says I can define all parts of a right triangle and use the Pythagorean theorem to solve for missing side lengths. Our learner right responsibility for today is to be open to embracing errors. You're gonna make mistakes, that's okay, it's a part of math. It's how we learn. So be open to making those errors and learning from them. All right, so the first thing I want you to do is think about what is a right triangle and what symbol do we use to represent that it's a right angle. Go ahead, take a moment and think about it. So a right triangle just means that it's a triangle where one of the angles is 90 degrees. That's all it is. And remember, if we have our triangle that looks like this, a right angle is symbolized with that little square right there. That little square is what we use to symbolize the right angle. So now I want you to take a look at my hippo. And we're going to define some things. So if you notice, one of the words that we have on here we've already learned, and it's adjacent. And if we remember, adjacent just means next to. Right? And so when we're talking about this, we're saying that the adjacent line is the line next to the angle in question. So if we're over here looking at angle A, we're going to say that line B is adjacent to angle A. It's the line next to that angle. So that's adjacent. The other one that we have is opposite. And I think we know what opposite really means, right? It's on the other side of the angle in question. So again, if we're looking at angle A, the one opposite is going to be line A with that lowercase a. It's opposite. It's all the way on the other side of the triangle. And the other one that we have is labeled with a hippo, and it says hypotenuse, and it makes me giggle, but the actual word for it is hypotenuse. Hypotenuse. And in reality, it makes a lot of us think of the word hippo, which is why it's here. And so this hippo, our hypotenuse, is always, always, always that diagonal line that is opposite from angle C. Always. It is always opposite from that right angle. And again, it's actually called a hypotenuse, but if you tell me it's the hippo line, I'll know what you mean. But shoot for using the word hypotenuse. So now I want you to look at this one. And I want you to tell me what's different. Take a moment and think about it. So if you notice, this one, instead of saying opposite and adjacent, just say leg. And that's totally okay, right? We generally use the phrase leg when we're talking about the sides themselves and not about the angles at all, right? So here we have that this angle is X, but if we're not talking about it at all, we're just going to say that this is a leg and this is a leg. And that's really all that we need to know for it. So just realize opposite and adjacent and leg, they're all the same when it comes to triangles. But no matter what, this hippo is still called the hypotenuse. All right, so there was this guy, and his name was Pythagoras, and he was a pretty cool dude. And here's what he said. The art of living happily is to live in the present. Whew, I love that quote. It's such a great quote. It's not a math quote. We gotta try again, because this is math. He also said, if a triangle is a right triangle, then the formula blank will be true. Now I want you to take a moment and I want you to think about whether or not you know what that formula is. Go ahead and think about it, because I think you do. All right, so if a triangle is a right triangle, then the formula a squared plus b squared equals c squared will be true. And this formula right here, that I'm sure you know, is called the Pythagorean theorem. Right, so just like we said with our goal for today, we're going to use the Pythagorean theorem. Well, this is what it is. This is that Pythagorean theorem. So now we're going to use it in actual context. So we're going to try it out. We're going to find the missing side length of this right triangle. I'm telling you it's a right triangle, so we don't actually need the square, but it's right there that I just drew in. It's fine. It's cool. I told you it's a right angle, so it's fine. We also need to identify the legs and the hypotenuse. And I'm just going to say it right now. This side length of 12 and this side length of 5, those are my legs. Those are the legs, and x is my hypotenuse, because that's the part that's across, it's opposite of that right angle. So now, remember, we have to use the formula a squared plus b squared equals c squared. That's the Pythagorean theorem. And c is always the hypotenuse. Always. Always, always, always. It doesn't change. But a and b, they have a little bit more variation to them. So I'm going to say that my a value is 5, my b value is 12, and c, well, that's what we're searching for. So I'm going to take these and I'm going to plug them in to my Pythagorean theorem. So I'm going to say 5 squared plus 12 squared equals c squared. Now you can either say c squared, or because the actual value of it is x, you can put x squared. That's totally fine as well. Maybe I'll change this to an x for the purpose of this activity. But so now we're going to actually go through and we're going to solve these. So 5 squared, 5 times 5 is 25, plus 12 squared, which is 12 times 12, is 144, equals x squared. Now, we don't know what x is, so we just have to leave it as x squared, and that's okay. But I'm going to combine 25 and 144, and that's going to give me 169 equals x squared. Now, I need you to think way, way, way back to the beginning of the year when we did squares. And we said that squares and square roots were inverse operations, right? Now, I don't care what x squared equals, right? I wasn't given x squared as my side length. I was given x. So I need to get rid of the squared. And the only way that I can do that is by taking the square root. Commandment number 1, whatever I do to one side, I have to do to the other. So I'm going to take the square root there as well. So the square root of x squared is just going to be x equals the square root of 169. Now, remember also that square roots have two answers, both the positive and the negative. But let's think about this. If I'm needing length, there's no such thing as negative length, so I just want the positive. And so the square root of 169 is going to be 13. So C equals 13. My hypotenuse length is 13. Now we could have also changed this, and we could have said that A was 12 and B was 5, and we would have gotten the same exact answer. So don't stress out about which one's A and which one's B. The only one that really, really matters is C. So now I want you to go ahead and try them out on your own. Go ahead and pause the video while you do that. All right, so here are those side length answers for the hypotenuse. Remember, the other ones are all legs. Those diagonals are the hypotenuse. I didn't do all of the work for it, but if you did not get these answers, double check to make sure that you are squaring properly and not multiplying the number by 2. So what did you notice about all of these triangles? Take a moment and think about it. One thing that I noticed was that all of these answers were nice, pretty answers. And in all honesty, pretty answers don't always happen, and generally in geometry, they don't happen. It's really actually uncommon for them to always be nice, pretty answers. And the variable can go literally anywhere. It can be the A, the B, or the C. So let's work on this one together. So I'm going to say that my A is 10, my B is my X value, right? We don't know what that is, and C is 15. Again, that C value cannot change. That has to stay at 15. Has to. So I'm going to say 10 squared plus X squared equals 15 squared. 10 times 10 is 100 plus X squared equals 225. In order to get X squared all by itself, I need to use my inverse operations and subtract 100 from both sides, and I end up with X squared equals 125. All right, and then just like that previous one, we need to take the square root of both sides, and we end up with X equals, If you look back at your warm-up, and you look at all those perfect squares, 125 is not on that list, because 125 is not a perfect square. So we're really just going to leave this as the square root of 125. We're really going to. In later math classes, you will figure out how to reduce this and simplify it so that it's not quite so large of a number on the inside. But for the purposes of this class, we're just going to leave it as X equals the square root of 125. So now, again, hey, can you load? There we go. I want you to try it out. Pick one of these problems and solve for X. Go ahead, pause the video while you do that. All right, did you get the answers? Again, if you didn't get these numbers, double check, make sure that you are putting them into the equations in the correct place. Right, this one is my C value, this one is my C value, this one is my C value. So all those need to be the C's, but your A's and B's can change. But make sure that you are also squaring properly. All right, so now we've learned a lot today. The last thing I want you to do is to write down something that you already knew and something that you learned. And that's it for today. Until next time, I'll see you later. Love you, bye.